Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the May 2015 Grade 9-10 Contest, question 18, which also came up in the Grade 11-12 contest. So the question is, line segments AB, BC, CD, and so on are the sides of a regular polygon. Each one of these is also the side of a square as shown in the diagram. What is the angle BQP if the polygon ABCDE has 12 sides? Okay, so we want to find out what the angle BQP is. Now, since it's a regular polygon, we can see that each side is the same length, and therefore each of these squares must have the same size. And that means that the line BP and the line BQ must both have the same length, and therefore the angles BQP and BPQ would both be the same. And since we know that the sum of interior angles in a triangle are 180 degrees, that means if we found out the angle PBQ, which is this small angle, well then of course we would be able to find out these angles. Alright, now if we put a circle around B, that would be 360 degrees, well then we would already have 90 degrees here, 90 degrees here would be 180, and then to find out the angle PBQ, we would only have to find out the angle ABC. So now we have to think, how can we find out the angle ABC? Well, we need to find a formula for the sum of interior angles of a polygon with n sides. Alright, now let's look at the board. Now, of course, we know that the sum of interior angles in a triangle is 180 degrees. Now, if we look at this quadrilateral, we can see that, of course, we can draw a diagonal. Now, after drawing that diagonal, we can see that there are two triangles. Well, of course, one triangle has a sum of 180 degrees for the interior angles, but now we have two of those, so we must do 2 times 180, which would give us 360 degrees for those interior angles in this quadrilateral. And now, in this pentagon, we can see we can draw one diagonal here, and now we can draw another diagonal. And here we had one triangle, here we have two triangles, and here we can see that we have 1, 2, 3 triangles. So we would have 180 degrees for the sum of interior angles for one triangle, but we would then multiply that by 3. Now we can see a pattern here. For here we have one triangle, two triangles, three triangles, so the sum of interior angles always goes up increases by 180 degrees for one more vertex. So that helps us now create a formula for a polygon with n sides. Now we would have n minus 2, because here we have, the triangle has 3 sides, but we have to do 1 times 180 is 180. And likewise for the quadrilateral, we have 2 triangles, 2 times 180, but we have 4 sides, so 4 minus 2. So we can see we have n minus 2 in brackets times 180 degrees. Now this would be the sum of the interior angles in a polygon with n sides. But now for a regular polygon, like in our question we are dealing with a regular polygon, if we want to find out each interior angle, well of course we must divide this by the number of interior angles, which would be n for a polygon with n sides. Okay, now from our question we know the regular polygon has 12 sides, so we can substitute in 12 for n. Okay, so now we would have, well, 12 minus 2 is 10 times 180 degrees is 1,800 degrees. And that would be divided by 12. that would give us 150 degrees. Okay, so now we can see that the angle ABC is 150 degrees. Okay, now for the angle PBQ, which is small angle, which is what we want to find out now. Well, to find out that, we have obviously the circle around B. It would be 360 degrees. And now we would subtract the 150 degrees for the angle ABC. And then we would also have to subtract, well, we have the 90 degrees here, and 90 degrees here is 180 degrees. And now that would give us, well, we have 360 minus 150 is 210, minus 180 is 30 degrees. Okay, so we know that angle PBQ is 30 degrees. And now to find out the angle BQP, well, that is then equal to, well, we have the 180, because the sum of interior angles for a triangle is 180 degrees. And we must subtract this by the 30 degrees for that angle. And now, since we know that both those angles are the same, we must then divide by 2. So 180 minus 30 is 150. 150 divided by 2 is 75 degrees. So therefore we know the angle BQP, which we wanted to find out, is 75 degrees. Alright, now a different way to find this same solution would be to see that this outside polygon has double the number of vertices as the inside the inner polygon. Because here we have 2 vertices for 1, 2 vertices for 1. So now instead of 12 sides, we would have 12 times 2 is 24 sides. So this outer polygon has 24 sides. So instead of having n equals 12, we would substitute in n equals 24 into this formula. And then after we find that, well, then all we would have to do is subtract 90 degrees, and then we would have that exact same specific angle of 75 degrees. If you'd like to know more about this contest, please feel free to visit our website at cariboutests.com.